Hi friends, welcome to all. In this video, we are going to solve this packet tracer activity, single area OSPFv2 configuration. Before coming to this activity, friends, if you like to get any CCNA version 7 online classes or any technical support, you can contact our team using our website. Link you will get from the description below. And also, if you like to get these type of technical videos in future, consider subscribing. And also don't forget to enable that bell icon near to the subscribe button so that you will get notification message whenever we upload a new video. Okay, back to our activity, single area OSPF v2 configuration. Here we can see our addressing table and objectives. Implement single area OSPF v2 in both point-to-point and broadcast multi-access networks. Background: you are helping a network engineer test an OSPF setup by building the network in the lab where you work. You have interconnected the devices and configured the interfaces and have connectivity within the local LANs. Your job is to complete the OSPF configuration according to the requirements left by the engineer. Use the information provided and the list of requirements to configure the test network. When the task has been successfully completed, all hosts should be able to ping the internet server. Instructions: configure the network to meet the requirements. Here we can see the requirements. Use process ID 10 for OSPF activation on all routers. Activate OSPF using network statements and inverse mask on the routers in the headquarters network. Okay, coming to our topology, here we can see headquarters with these three routers: P2P1, P2P2 and P2P3. So we will activate OSPF with the process ID 10. We will start from this router P2P-1 CLI. Okay, enable. Configure terminal, we will give in short. Then we will go to router OSPF process ID 10, right? Now we have to specify the networks. So before that, let me give this command, do show IP route connected, so that we can see all the directly connected networks. You have to start with the do command. Okay, now we will give the networks. Network, first we will give this, that is 10.0.0.0 space. Then we have to give it some wildcard bits, right? /30, that means it's 0.0.0.3. also we have to specify the area 0. Then we will go to this network, that is 10.0.0.8. then it's wildcard bits 0.0.0.3 and area 0. Also we will give this network 10.0.0.12, 0.0.0.3 with area 0. In the same way, we can do it in these routers P2P2 and P2P3. Coming to this router P2P2, enable conf t, and here we will go to this router OSPF10 and we have to give networks. Okay, let me give this show command, do show IP route connected, that means directly connected networks. Now we can give this network 10.0.0.0. then we have to give a wildcard bits 0.0.0.3, area 0. Next network, it's here 10.0.0.4. so whenever you get this message, you can press tab button from the keyboard. Okay, then wildcard bits 0.0.0.3, area 0. Then we can give this network, that is 192.168.1.0, and here we can see the prefix is /24. That means it's a wildcard bit 0.0.0.255 area 0, and the last network 2.0 192.168.2.0 wildcard bit 0.0.0.255 area 0. Okay, we will close this and then we will go to this router P2P3 CLI, enable conft, and here we will give router OSPF and process ID 10. Then we have to give the networks. Before that we will give the show command, do show IP route connected. Okay, then we can give network, but I will copy this instead of typing. Then we have to give its wildcard bits 0.0.0.3, then area 0. Next network we have, okay, 0.0.0. okay, we get some message process 10. okay, loading done, that's fine. Press tab 0.0.0.3, right, /30, yes. Then we have to specify the area 0 and last network 192.168.3.0/28. okay, press again tab. Then we have to give it a wildcard bit. So here we can see the prefix given is /28. That means its subnet mask will be 255.255.255.240. That means 240 plus 15, we will get 255, right? So we have to give the wildcard bit 0.0.0.15. okay, then we have to give the area 0. okay, so we done on all these three routers in this headquarters. Now coming to the next requirement, activate OSPF by configuring the interfaces of the network devices in the data service network where required. Also configure router IDs on the multi-access network routers as follows. For BC1 we have to configure this router ID. For BC2 we have to configure this router ID. Then for this BC-3 we have to configure this router ID. We will do this first. Activate OSPF by configuring the interfaces of the network devices in the data service network where required. So here we can see our data services, and we can see these routers BC-1, BC-2 and BC-3. First of all, we will do it in this router BC-1, and we can see this router used three interfaces. Let us see that serial 0/1/0, serial it's a gigabit Ethernet 0/0/0, and we have one serial which is connecting to this ISP cloud, that is serial 0/1/1. Hence here no need to activate OSPF for this interface serial 0/1/1 which is connecting to this ISP cloud, right? Okay, just we will go to this router, enable conft, and here let me give the command do show IP interface brief, so that we can see the interfaces used. Gigabit Ethernet 0/0/0, then serial 0/1/0, and here we can see the interface serial 0/1/1 which is connecting to the ISP. Here in this router we will go to these two interfaces and we will activate OSPF. First of all, we will go to the interface G0/0/0. okay, and here we will give the command IP OSPF, then we have to specify the process ID 10, then area 0. Also we will go to this interface serial 0/1/0. we can go to this interface from this mode itself. Type interface serial 0/1/0, right? And we have to give IP OSPF10 area 0, and make sure that you are not activated OSPF for this interface, that is a serial 0/1/1, which is connecting to this ISP cloud. Now we will go to this router BC-2, enable conft do show IP interface brief, and here we can see two interfaces. That's correct. We will go to interface G 0/0/0, and we will activate OSPF IP OSPF 10 area 0. Also we'll go to interface gigabit Ethernet 0/0/1 IP OSPF 10 area 0. Finally, we will go to this router BC-3, enable conft do show IP interface brief, and we can see two interfaces. We will go to interface G 0/0/0, and we will enable activate OSPF IP OSPF 10 area 0. Okay, then we will go to interface G 0/0/1. Here we can see that, and we will give IP OSPF 10 area 0. Okay, next requirement: configure router IDs on the multi-access network routers as follows. Okay, we will do it one by one. Here we can see BC-1. We will go to BC-1, and we have to set this router ID. Exit. Here we have to go to IP root. Sorry, it's a router. It's OSPF. We have to give process ID 10, and we will set the router ID, right? 6.6.6.6. Okay, we will go to BC-2, and we have to set this. Exit router OSPF 10 router ID 5.5.5.5. Okay, then we will go to BC-3 and set this router ID. Exit router OSPF 10 router ID 4.4.4.4. Coming to the next requirement: configure OSPF so that routing updates are not sent into networks where they are not required. Absolutely, because here we can see the local networks which is connected to these routers P2P-2, P2P-3, and even here also. That means we have to enable passive interface. Okay, we will do that. In this router, that is P2P-2, we have two LANs, and it's connected to these ports G0/0/0 and G0/0/1. That means that these two ports should be in a passive interface. So we can do that. Enable conft. Again, we have to go to router OSPF 10, and here we can give that command. Let me put a question mark, and here we can see passive interface command. You will give that passive dash interface, and we have to specify the interfaces. It's a G0/0/0. Also we have one more. Okay, we'll press up arrow from the keyboard so that we get the previous command we given. Here we have to change this interface from G0/0/0 to G0/0/1, correct? Coming to this router P2P-3, and here we can see a single LAN which is connected to this interface G0/0/0. So we will configure passive interface with this interface. Let's do that. Enable conft, and here we have to go to router OSPF10, and we will give a passive interface G0/0/0. Now coming to this routers, that is BC-2 and BC-3, and here we can see this interface G000, and here also we have G000. Okay, we will do that. Okay, we already in a router OSPF10. Here we can give passive interface G0/0/0, and coming to this BC-3 router OSPF10, here we can give passive interface G000. Now here coming to this router, that is BC-1, here we can see this interface, that is serial 0/1/1, which is connecting to this ISP cloud, right? So we have to configure passive interface for this interface also, so that this router will not send any routing updates to this side, I mean to this ISP cloud. Just we will do that. Okay, already we are in a router OSPF10. Here we have to give passive interface, that is serial 0/1/1. Okay, now we will go to the next requirement, that is configure router BC-1 with the highest OSPF interface priority, so that it will always be the designated router of the multi-access network. Here is our BC-1, and we can see our multi-access network here to this interface, that is G0/0/0, right? So we have to configure this priority in this interface G0/0/0 in this router BC-1. So just we will exit, and then we will go to that interface, that is G0/0/1. Sorry, it's a 0. Let me verify that. 000. Yeah, it's correct. And here we can set that IP OSPF. We have the priority command. Let me put a question mark, and here we can see priority, router priority. We'll give that command, and we will give the highest priority. Here we can see the highest number is 255. Coming to the next requirement, configure a default route to the ISP cloud using the exit interface command argument. Okay, we will configure this default route to this ISP using its exit interface, that is serial 0/1/1. So we'll go to that router. We have to go to global configuration mode, and we have to configure this default static route, right? We have the command IP route 0.0.0.0 space 0.0.0.0 space, then we have to specify the exit interface, that is serial 0/1/1. Next is automatically distribute the default route to all routers in the network. Yeah, just now we configured this static default route in this router, so that should be distributed to all other routers using OSPF. That means we have to use a default information originate command in this router. Okay, we can do that. We have to go to router OSPF, then process ID 10, then let me put a question mark, and here we can see default information. Let me give that then again a question mark, originate, distribute a default route. So it's originate. Okay, just I will end. Let me check the routing table, show IP route, and here we can see the static default route we set. Coming to the next requirement, configure the OSPF routers so that the gigabit Ethernet interface cost will be 10 and the fast Ethernet cost will be 100. Okay, we have to do that. That means we have to set the auto cost reference bandwidth. Okay, we will do it one by one. We will go to this router, CLI, enable conft router OSPF 10, and here we will give that auto cost or reference bandwidth. Let me put a question mark, and here we can see reference bandwidth RE. Then you can press tab so that it will this incomplete unique command will complete. Reference bandwidth, we will give the reference bandwidth in terms of megabits per second. So we will give 1000. Okay, just I will copy this command. Then we will go to this router, enable conft, sorry, here we have to give router OSPF 10. Then we will give that command, auto cost reference bandwidth. Then we will go to this router, enable conft router OSPF 10, auto cost reference bandwidth 1000. Now we will go to these routers, BC-1, enable conft router OSPF 10 and auto cost reference bandwidth. Then we will go to this router, BC-2, enable conft router OSPF, it's a 10, and here is the command, and finally BC-3, enable conft router OSPF 10, auto cost reference bandwidth. Next requirement is configure the OSPF cost to value of a P2P-1 interface serial 0/1/1 to 50. Here we can see our router P2P-1 and this interface that is a serial 0/1/1. Let me check this interface. Yeah, it's here, which is connecting to this P2P-3. We will do that configuration. We will exit from here, then we will go to that interface that is serial 0/1/1, and here we will set that IP OSPF cost 50. Okay, now coming to the final requirement, configure the hello and dead timer values on the interfaces that connect P2P-1 and BC-1 to be twice the default values. Okay, we will do that, but before that we should know what is the default value of this hello and dead timer, right? So we can go to any one router and we can verify that what is the default values. Here we will give a show IP OSPF. Let me give, I'll put a question mark and I will give interface. Okay, yes, and here we can see hello is a 10 and dead is 40. So dead will be 4 times of this hello. So as per the instruction, we have to configure this hello and dead timer twice the default values. That means we have to configure the hello interval as a 20 and a dead interval as 80. We have to go to that interface and configure this hello interval as well as this dead interval. Here we can see that interface serial 0/2/0, which is connecting to this BC-1. So we will go to that interface, exit and go to interface serial 0/2/0, right? And here we will set IP OSPF, and here we can see hello interval. Okay, and here we can see it should be given in seconds. We will give it 20. Also we will set IP OSPF dead interval, that is 80. Next we will go to this router, that is BC-1, and here we can see the interface. It's a serial 0/1/0. We will go to that interface, that is a serial 0/1/0, and we will set IP OSPF hello interval first 20. Also we will set IP OSPF dead interval 80. Okay, now as they specified, all hosts should be able to ping the internet server. Okay, just we'll go to PC1 desktop command prompt, and we will test that. We will ping to this internet server, ping to 203.0.113.100, and here we can see we get the replies. Let me try from one or two PCs. I will try from this server. Okay, also we will try from this PC too. It's working. Okay, that's all in this activity, that is a single area OSPFv2 configuration. Here we can see our completion status. It shows 100%. Now, dear friends, if you get any doubt or any trouble during this configuration, you can contact our team using our website. Link you will get from the description below. And if you like our video, give a thumb and don't forget to share with all your friends. Stay tuned and we will meet again with the next video. Thank you.